C1, graphs and transformations of graphs. So we have a list of equations here at the bottom, and we have the same amount of graphs. So we just need to match the right equation to the correct graph. So if I have a look at this first equation, I have a negative gradient. So I know that because I have a minus there. I also know that it is linear. And I know that the y-intercept is at +1. So looking at the graphs that I've given, well, I've only got two that are linear, which is 2 and 4. And because I know that I've got negative gradient and I've got a positive y-intercept, well, that could be 1. And then I've got my negative gradient because of the direction of the line. So that means that this first equation matches up with picture number 4. So let's have a look at the second one. So we've got y equals 3 to the power of x. So for this equation, we have y equals 3 to the power of x. So this is what we call an exponential graph. And you'll learn more about this in Core 2. But an exponential graph looks like number 7. So y equals 3 to the power of x matches up with 7. So for the next one, y equals x squared plus 2x minus 1. So here we have a quadratic. And we know that it's going to have a y-intercept at -1. So if I have a look, I'm looking for a quadratic which has a positive x squared, so it's going to be a U shape, which cuts the y-axis at -1. So there's only one positive x squared function, and that looks like it could be -1. So my third one matches up with number 9. So here I have a cubic, which is positive. So I know that it's going to have that shape. And also I know that it's going to pass through the origin because there is no plus constant on the end. So the only cubic graph that passes through the origin and has the correct directionality so that must be this graph number 1. So if we have a think, this value here would end up being -2 because -2 cubed minus 4 lots of -2 would give us -8 plus 8, which would give us 0. And it crosses through the origin, and this value here would be 2 again. Okay, so that matches up with graph number 1. Let's have a look at the next one. So here we have a quadratic again, but now I've got a minus before the x squared, so I know it's going to make this shape, and the y-intercept is going to be at +3. So I have a look. This is the only quadratic with a negative gradient, and that looks like it could be +3. So that means that this matches up with graph number 3. The next one, so this is a positive linear graph which has y-intercept at -1. So I'm looking for a positive graph, which is linear and passes through y equals -1. So linear with a positive gradient, and that could be y equals -1. So that means that this equation matches up with equation number 2. So the next one, y equals 2 over x. Again, later on in the course in maths, you will get used to seeing this as the graph of 1 over x, which is this one. So we have asymptotes at the x-axis and at the y-axis. An asymptote is a line that the curve gets close to but never actually touches. So this matches up with 5 because it's the graph of 1 over x times 2. So this next one, we have a cubic, which this time is negative. So that means it's going to have this shape, but again, it's going to pass through the origin. So the only graph that has that shape and passes through the origin is number 6. So number 6 is y equals -x cubed. And the last one, here we have another cubic which has a negative gradient again, so it's going to have this shape because of the minus sign in front of the x cubed, and we know that it's going to have a y-intercept at +2. So looking at the graphs, the only one that has that shape is number 8, which is the only one left, so that would be 2. So obviously number 8 is the graph y equals -x cubed plus 3x plus 2. Okay, so the main thing to notice here is how much the gradient changes the graph, so whether it's negative or positive, and also that the numbers, the constant terms on the end, represent where the y-intercept is on the graphs.